All right, folks, it's Bass Action back in action here. This is our second example of how to graph a rational function. So I'm going to walk you through the steps again, and just to remember that I'm going to list all the steps. Any of the steps could be used as an individual question, and if I ask you to graph something, I expect you to know these steps without any prompting. All right, let's jump into our step one. So our step one, remember, has to remain as step one. It can't go anywhere else. And it's going to be to factor and find the domain. Now we can find this domain right off the bat before we even factor, because we can clearly see that the denominator is an x minus 4. We could set that equal to 0 and immediately get our domain of x such that x is not equal to 4. Okay, so that gets us our domain, but we still need to factor this numerator. Now we've got 4 terms here, which is our clue that it's probably going to factor by grouping. So we're going to think in our 2 groups, I'm going to factor the GCF out of the first group. That's going to be a 2x squared. That's going to leave me with an x minus 4. And then out of the second group, I'm going to factor a positive 3, and that's going to leave me with an x minus 4. And then I'll have a 2x squared plus 3 times an x minus 4. That is my numerator. And then if I want to rewrite my denominator just to make this a little clearer for myself, I'll have an x minus 4. So we factored, we found our domain, and our second step then says to write our function in its lowest terms. So we can see that these x minus 4s are going to cancel. So our function in its lowest terms is r of x is 2x squared plus 3. So what you should notice here is that this new function is actually not a rational function anymore at all. It's just a parabola, which means a whole bunch of our questions are going to drop out and they're not even going to be important for us. But step 3 is still important, and that's to identify the holes. And remember, holes happen when something cancels. And since that x minus 4 canceled, we will in fact have a hole at x equals 4. So we're going to go ahead and evaluate. So we're going to say r of 4. So we'll have 2 times our 16 plus our 3. So we're going to have 32 plus our 3 is 35. So we're going to have a hole at the point 435. Okay, remember, we'll use that when we get to our graphs. Now, finding any vertical asymptotes. Well, that doesn't apply since our graph is a parabola and parabolas don't have asymptotes. Finding the oblique asymptotes, again, that doesn't apply because we don't have any asymptotes on a parabola. Of course, if we don't have a horizontal or oblique, we certainly can't discuss whether or not it would cross, so that gets eliminated. We can still find intercepts, though. So we can still let our x equals 0 and get y equals 0 plus 3. So we'll have a y-intercept of 0, 3, which should already make sense because we have a parabola that's been shifted up 3. Then we're going to let our y equal 0. And if y is 0, we're going to have our 0 and our 2x squared plus 3. We'll get a negative 3 is 2x squared. And from here, I can already see that if I divide by 2 and take the square root, I'm going to end up with something imaginary, which means there are no x-intercepts, which again should also make sense if we're thinking about an upward turning parabola that's been shifted up 3. Okay, so now let's come down here to the bottom and we're going to put this all together. Other steps that we don't have to do, don't have to worry about any analyzing around the asymptotes because there aren't any asymptotes. So we just need to create a little sketch. So we're going to show this as a shifting up 3, give ourselves a nice parabola. It doesn't really matter whether it's perfectly to scale, although mine looks pretty unbalanced here. So I'm going to go ahead and I'm going to erase part of this. I'm going to make mine look a little bit more symmetrical. I think I could improve that. We'll make that look a little bit better there. And then we want to remember to go back and put in the hole at the point 435. So I'm going to put a little open circle here. I'm going to label this 435, and I can even go back and erase that little bit that's right inside the circle so we can see that it looks like a nice hole. And that's all we've got. So the big idea on this one is to recognize that even though you might start with a complicated looking rational function, you might in fact end up with the graph of a basic item that comes straight from your library of functions. So don't get so wrapped up that all of the steps always apply. Sometimes they don't, because everything cancels out.